Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you all doing well. Lecture for grade 8, Chemistry, chapter number 1, lecture number 6, and here is Mrs. Saira Jamal. Student, today lecture is about the chemical species. What are chemical species? Chemical species may be atoms, ions, molecules, molecular ions, free radicals, all these are called chemical species. We will discuss these one by one. About atoms, you know that atom is the smallest particle of an element. I told you in my previous lecture that elements are made up of smallest fundamental particle, and those fundamental particles are called atoms. All the elements, they are made up of smallest particles, and those smallest particles are called atoms. It can or cannot exist independently, except the group number 8 elements, which I told you in my previous lecture, that in periodic table, the group number 8 elements, which are also called noble gases, they only exist in the atomic form. The rest of all the atoms, they form molecule, and they never exist independently or in the free form, and they take part in a chemical reaction because they never exist independently. That's why I said can or cannot. Can for noble gases, that they can exist independently. The rest of all the atoms, they cannot exist independently, and they will react with other atoms and then form molecules or will form any compound. Atom is electrically neutral. Atom is electrically neutral means it does not have any charge, because the number of protons and the number of electrons are always same. So equal number of positive charges and equal number of negative charges, they cancel the effect of each other. As a result, the atom has no charge. Examples of atoms are sodium, calcium atom, aluminium atom. These are the examples of, means like uh, these elements are made up of atoms. Again, I told you the smallest particle of sodium will be atom, calcium atom, aluminium atom. So elements, I told you before that they cannot be converted into simpler substances. Second chemical species is ions. It is the smallest unit of an ionic compound. I told you ionic compound, they are made up of ions. They did not contain molecules. So all the ionic compounds, they are made up of ions. Like sodium chloride, it is made up of sodium ion and fluoride ion. It cannot exist independently and is surrounded by oppositely charged ions. It cannot exist independently, same like the atoms. Ions are also highly reactive, and they never exist alone or in free state, and definitely they combine with opposite charge. Opposite charge mean if the ion is positive charge, it will surrounded by the negatively charged ion, or if it is a negatively charged ion, it will be surrounded by the positively charged ion. So depending upon which charge is there, it has a net charge either negative or positive on it. Ions, you know, they may be positive or they may be negatively charged ions. Examples of ions are sodium ion, calcium ion, aluminium ion. These are the examples of ions. Now we have difference between atoms and ions. Ion and atom, what are the main differences? Atom, it is the smallest particle of an element, and ion is the smallest unit or particle of an ionic compound. Second, it can or cannot exist independently and can take part in a chemical reaction, as I told you. And again, ions also cannot exist independently and is surrounded by oppositely charged ions. Atom is electrically neutral, it has no charge, while ions has positive or negative charge. Ions are charged species formed from an atom. When an atom gain or loses electron, then it forms ions, or chemically bonded group of atoms by adding or removing electrons. Ions are not only atoms. Ions may be group of atoms. Group of atom mean it may be a molecule. Definitely, atoms combine together, and then they form molecule. So ions are uh, made up of atoms, as well as they may be made up of molecules. Group of atom mean molecule. By adding or removing electrons, so there are two types of ions: monoatomic ions. From the name indicated, mono means one and atomic means atom. So it means that monoatomic ions, they contain only one atom. And the second type of atoms are called the polyatomic ions. Again, poly means many and atomic means atoms. So they are also called molecular ions because they contain more than one atom. So there are two main types of ions: monoatomic ions and polyatomic ions. Monoatomic ions, I told you, they contain one atom, and they are further of two types: anions and cations. When an atom gain electrons, it forms negatively charged ions, and they are called anions. For example, chloride ion, oxide ions. You can see these ions has these ions have negative charge, so these negatively charged ions are called anions. Cations: when an atom loses electrons, it forms positively charged ions called cations. You can see Na plus and Ca plus. Sodium ion and calcium ion, they have positive charge, so they are called cations. Then the second class, polyatomic ions or molecular ions containing more than one atom. There are further two types: molecular anion and molecular cation. Molecular anion: when a molecule gain electron, will form a negatively charged ion, because gain of electron will make anion, called molecular anion. For example, you can see phosphate ion minus 3 charge, carbonate ion minus 2 charge, oxygen minus 2 charge. So this is O2, oxygen molecule with minus 2 charge. So they are called molecular anion. And when a molecule loses electrons and will form a positively charged ion, so it is called molecular cation. For example, ammonium ion with positive charge. Again, this is O2, O2 with positive 2 charge, nitrogen molecule. So it will have a positive charge. So these ions have positive charge, and they are called molecular cation. Ions are of two main types: monoatomic ions and polyatomic ions. The polyatomic ions are also called molecular ions, and monoatomic ions, from the name indicated, they are made up of one atom, and the polyatomic ions, they are made up of more than one atom. So definitely, I told you, when atoms combine together, they'll form molecule, and when molecule will gain electron, so will have negative charge, and when molecule will loses electron, will form a positively charged ion called cation. And in this case, when an atom gain electron, will form negatively charged ion, and when an atom loses electron, will form a positively charged ion called cations. Difference between molecule and molecular ion. Molecule, it is the smallest particle of a compound. I told you compounds are made up of smallest particle, and that smallest particle of compound is molecule, which can exist independently. Molecule can exist in free form, like water molecule, like ammonia molecule, like oxygen molecule, hydrogen molecule. They exist independently or in free state, and shows all the properties of that compound. And definitely, all the properties of a compound, it depend upon the molecule, which type of molecules they are present in a compound, and then all the properties are same like that molecule. Molecular ion, it is formed by gain or loss of electrons by a molecule. I told you in the previous slide, molecule may gain or loses electron and will form molecular ion. And again, they may be negative ion or maybe positive ion. And molecule are always neutral. They have no charge because their valency is completely filled or their outermost shells are completely filled, so they have no charge. Molecule, it is formed by the combination of atoms. Many atoms combine together and then they form molecule, while the molecular ion, it is formed by the ionization of a molecule. Ionization of a molecule means when a molecule loses or gain electron. So, or in other words, you can say that when some radiations are like when we heat molecule, especially a gas molecule, what will happen? Electrons will emit out, or it will gain electron and then convert it, or then it ionizes. Because mostly when electrons are eject out from a molecule, what will happen? That molecule will have positive nucleus and electrons will eject out, so negative electron. Then it is called ionization of a molecule or breakdown of a molecule. Molecule is a stable unit because outermost shells of the atoms are completely filled. So this molecule does not need to react. While molecular ion is unstable, the outermost shell of the ion is not completely filled. So it is a reactive species and it will try to get the stable state by reaction with other substances. So by reacting with other substances. Why an ion has a net positive or a negative charge? As I told you, ion may be positive or maybe negative. We have the example of sodium ion. Sodium atom, you can see it have 11 protons in the nucleus and it have 12 neutrons in the nucleus. So positive charges are 11 and negative charges are again 11. You can see 2 electrons or negative charges in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. So 8 plus 2, 10, and this 1 electron is 11. So there are 11 electrons in the uh, sodium atom, but you can see this outermost shell has only 1 electron. So to complete this outermost shell, sodium needs 7 electrons. Gain of 7 electron is not possible by sodium. So the easiest way is sodium will lose this 1 electron, loss of 1 valence electron, and losing 1 electron will make the sodium atom highly stable. Now its outermost shell is completely filled, it has 8 electrons in it. So sodium, this sodium atom when loses 1 electron, it is converted into the ionized state, and that ionized state is called cation because sodium has a positive charge. As it loses 1 electron, so sodium will have 1 positive charge. 1 positive charge means that sodium loses 1 electron. So sodium from atomic form by losing electron is converted into the ionized form or into the ionic form. Sodium has a nucleus of 11 protons and 12 neutrons. Thus, its nucleus has how much charge? Definitely the charge on nucleus is only due to the presence of proton because neutrons are neutral particles. So as there are 11 protons in the nucleus of sodium atom, so so charge on nucleus is positive 11. Around the nucleus, electrons are present in the shell. So around the nucleus in the ion state, not in atomic form, in the ionic state, when sodium loses 1 electron, so there are 10 electrons left. And now the total negative charges are minus 10. The charge on the ion is now, what is the total charge on the ion? It has 11 protons, means 11 positive charges, plus how many electrons, how many negative charges? 10 negative charges. So plus 11 plus minus 10 will give us the answer plus 1. That's why the total charge on sodium is plus 1 when we write it in the form Na plus. Then we have the self-assessment exercise, and in this self-assessment exercise, the first example is that why the atoms they can form anion and cation. The first example is for oxygen atom, that why or oxygen has a -2 charge. So you can see the structure of oxygen. There are 8 protons in the nucleus of oxygen and 8 neutrons in the nucleus of oxygen. And how many electrons are surrounding it? You can see 1, 2 in the first shell, and 1, 2, 3, 4, 5, 6, 6 electrons in the outermost shell. And to complete the outermost shell, this oxygen needs 2 more electrons. Then it will have 8 electrons in the outermost shell, and then the outermost shell of oxygen will be completed. So oxygen need 2 electrons to complete its outermost shell. You can see in this case, this oxygen atom will gain 2 electrons, and gain of electron will form negatively charged ion, which are called anion. So oxygen atom will convert it into oxygen ion, which is called oxide ion. Now you can see how many electrons are present in the outermost shell after gaining 2 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Now 8 electrons are present in the outermost shell of oxygen. So the outermost shell of oxygen is now completely filled, but in which form? In the ionic form, which have -2 charge. It is called oxide ion, and this is also called anion because negatively charged ions are called anion. Oxygen has a nucleus of 8 protons and 8 neutrons. Thus, its nucleus has a total charge of how many protons are there, how many positive charges are there, plus 8, and how many negative charges are there. When oxygen gain electron, it have now total 10 electrons. So total charge on the ion will be plus 8, 8 protons, and 10 electrons will give us the answer -2. So net charge on oxygen is in the form of ion is -2. Second example is for magnesium ion. Why magnesium ion has +2 charge? So magnesium ion has +2 charge. The reason is that you can see magnesium has 12 protons in the center, so it have positive charges 12, and electrons which are present in the outermost shell are 2. Total 12 electrons, so 8 electrons in the second shell and 2 in the first 10, and the remaining 2 are present in the outermost shell. So to complete the outermost shell, magnesium need 6 more electrons. Gain of those 6 electrons is not possible by magnesium. It will loses those 2 electrons, and after losing those 2 electrons, you can see magnesium ion will have +2 charge. Now you can see this outermost shell is empty because those 2 electrons magnesium loses. This is called 2 electron lose by magnesium atom, and it will give us magnesium positive or divalent cation. The positively charged ions which are formed by when the atom loses electrons are called cation. So magnesium will form cation. Now magnesium in the nucleus have 12 protons and 12 neutrons, so total positive charges are 12. And around the nucleus in the ion there are 10 electrons because 2 electrons the magnesium will loses, so 10 electrons will left. So due to those 10 electrons, the negative charges are -10. The net charge on the ion or the total charge on the ion will be +12 plus -10. So it will give us the answer +2. It means the magnesium ion has positive charge, that is +2. Another example is for the sulfide ion or for the sulfur atom. You can see sulfur atom has 16 protons and 16 neutrons in it. So how many positive charges are on the nucleus? 16 positive charges. And how many electrons are present in the shell? 2 electrons in the first shell, 8 electrons in the second shell, 10, and 6 are left. So 6 electrons are present in the outermost shell of this sulfur atom. Now to gain 2 more electrons to have 8 electrons in the outermost shell, so sulfur needs 2 electrons. Then sulfur will gain those 2 electrons. You can see sulfur will gain 2 electrons, and then we'll have 8 electrons in the outermost. So these 2 electrons which sulfur gain. So by gaining 2 electrons, the sulfur has now 8 electrons in the outermost shell. Charges on sulfur. Sulfur has 16 protons and 16 neutrons. Due to 16 protons, it has 16 positive charges. And around the nucleus in the ion, it has 18 electrons. 16 electrons were present before, and 2 after gaining 2 electrons. Then electrons are now 18. So total negative charges are -18. Net charge on the ion is Positive 16 plus negative 18 will give us the answer negative 2. That's why the charge on sulfur is, or sulfide ion is, minus 2. This is how the atoms have positive or negative charges. The next topic is about the free radicals. What are free radicals? These are atoms which has unpaired electrons. So they have odd number of electrons. These are atoms. These are the atom which has unpaired. Unpaired means you know that all the atoms, the electrons are in pair. In pair means if there are 4 electrons, so 2 will make the 2 pairs, and if there are 6, so then again 2 will make 3 pairs. Unpair means that one electron is alone. It does not have any other electron to make a pair with it, so at least one of the electron will be in the unpaired form. So definitely the electron which will left in unpaired form means that it has odd number of electrons, because odd number of electrons have no pair to become paired up. They can exist in solution as well as in air. Free radicals are present in air. Free radicals are also present in solution. So they can exist in solution as well as in air. They may form in the presence of sunlight. Mostly the free radical, they are formed in the presence of sunlight. How? Inshallah, you will learn in the higher classes. They bear no electrical charge. There is no charge on them because they are not gaining or losing electrons, so they are neutral. They are highly reactive. They are highly reactive means that these free radical, they have unpaired electrons, so definitely to get stability they will react with another radical and then in turn will get stabilized. So free radicals are highly reactive. Examples of free radical, you can see this first case. How many electrons are present in the outermost shell of fluorine? 1, 2, 3, 4, 5, 6, 7. 7 electrons are present in the outermost shell of fluorine. This is called the Lewis structure of atom. Lewis structure. Lewis is the name of the scientist, and he presented the electrons present in the outermost shell of an atom by putting dots. These dots actually represent the electrons which are present in the outermost shell of an atom. So as 7 electrons are present in the outermost shell of fluorine, and 7 is an odd number, and you can see this electron is unpaired. There is no electron to make pair with it. So this means that this is an example of free radical. The atom which has odd number of electron, the atom which has unpaired electron, the atom which has no charge, it is highly reactive. So, and it is formed in the presence of sunlight. This is an example of free radical. You can see boron again has one pair here, but this electron is alone. There is no any other electron to make pair with it. So boron is again a free radical. Nitrogen, you can see it has 5 electrons in the outermost shell. 1, 2, 3, 4, and 5. 5 again is an odd number, and electrons are present in unpaired form. So again an example of free radical. Differentiate between ions and free radical. Ions, these are the atoms which bear some charges. Ions, I told they may be anion or cation, so will have positive or negative charge. Free radical, these are the atoms that have odd number of electrons, and they can exist in solution as well as in air. While solution, they always exist in solution form or in crystal. That means in solids. Crystals like sodium chloride is a solid crystal, and it has sodium ion and chloride ion. Again, if we dissolve sodium chloride in water, it has sodium ion and chloride ion. They will separate out. So ions may exist in solution form or in crystal lattice, and means in solid compounds. While they exist in solution as well as in air, not in the solid in solution but in air. Their formation is not affected by the presence of sunlight. For ions formation, sunlight is not important. Ions may be formed by dissolving in water, or they may be formed by heating an ionic compound. There is no importance of sunlight or effect of sunlight on ions. But when sunlight fall on neutral atom, that neutral atom may convert it into the radical form. So they are formed in the presence of light or sunlight. There are two examples, or there are two chlorine atoms and ions, and you have to identify which one is radical and which one is ion. So the negative sign on chloride ion is a clear identification of the ion. That is, I told you that the ions will have positive or negative charge on it. So this is chloride ion. While in this case, you can see it has the chlorine atom which has 7 electrons in the outermost shell. This chlorine has 8 electrons, and this chlorine has 7 electrons in the outermost shell. So it means that odd number of electrons are present and unpaired electron is present. So this is an example of free radical. Self-assessment exercise: identify ions, molecular ions, and free radicals from the following species. First one is cyanide ion. Cyanide, carbon, and nitrogen. So carbon and nitrogen, they combine together and they form molecule, because molecules are made up of more than one atom. In other words, you can say this molecule is a compound because it is made up of different atoms. So this compound or molecule which have negative charge, we will call it molecular ion. And molecular ion, which molecular ion? As it has negative charge, so molecular anion. Okay, negatively charged ions are called molecular anion. The second one, you can see a dot on it which has only one electron on it, and it is unpaired form. One is odd number, so this C and with a dot is free radical. Helium with a positive charge, so again helium is only one element. It is called a noble gas and it is ion. As it has positive charge, so this is cation. Nitrogen with a negative charge, nitrogen again is an element, it is ion. And which ion? With a negative charge, it is called anion. Oxygen, oxygen, it has 1, 2, 3, 4, 5, 6 electrons in the outermost shell. So it's even number. 6 is not an odd number, it is even number. So this is just a neutral atom. And nitrogen having 5 electron, 1, 2, 3, 4, 5. 5 is odd number, and it has unpaired electrons. So this is an example of free radical. In new books, methane is also there, CH4 with positive charge. So CH4 with positive charge is molecular ion. And which molecular ion? Cation, because it has positive charge. But in this book, methane is not present. In new book, methane is there. Then the next topic is about the representative particles of elements and compound. Elements are composed of atoms, compounds are composed of molecules, and that's why we say that the term representative particle refer to species present in a substance. These species may be atom, molecules, or if it is ionic compound, we will use the term formula unit. For instance, water exists as molecule and carbon exists as an atom. Sodium chloride exists as a formula unit. So example 1.5, identify representative particles of elements and compound. You can see in this diagram A is made up of two similar balls. And I told you it is an example of element because elements are made up of similar atoms. One atom or more than one atom, but if they are similar, so we call it element. This may be O2, H2, or N2. So this is an example of element. Again, the C is made up of two similar balls, so element. E again is made up of two similar balls, so element. But B, you can see the central ball is big and the side two balls are small. So that molecule which is made up of different atoms, it is called compound. So this B is compound. D, if you see, there are three balls, but all the three balls are of same size. It means that this may be ozone, O3, which is made up of three oxygen atoms, and all the three oxygen atoms are same. So similar atoms combined together in a molecule, that is called element. So D is again an element. F, center ball is big and the side three balls are small. So this is a molecule which is made up of different atoms. This is compound. So A, C, D, and E, they are elements because they are made up of similar atoms. But B, and F, they are made up of different atoms, so they are called compounds. Okay, they are called compound. B and F are called compound. Uh, Identification, again, I am revising. How will you identify which one is element, which one is compound, and which one is mixture? And by following these points in your mind, you will be able to solve the next self-assessment exercise. So listen it carefully. You can see all the red balls. All these red balls are similar, and these are atoms. So we will say that this box contain elements. This box contain what? Atoms, and these atoms are called elements. That may be helium, maybe neon, kryptons, because I told you these are the only elements which exist in monoatomic form in one atom. So element. Now if similar balls or similar atoms combine together and then they form a molecule, it is called element. This may be H2 or O2 or N2, but as they are made up of similar atoms, so again they are elements. In this case, you can see there are two similar ball and one different ball. That may be water, because two hydrogen atoms are same and oxygen is different. So, but as we have two types of ball or two color balls, red balls and blue ball, and I told you when different atoms combine together and then they form molecule, it is called compound. So these are compounds. And in this case, again, two different atoms combine together, red and blue, and then they form a molecule. So again, these are compounds. Okay, this is compound, this is compound. Then coming toward the next box, in this box you can see we have two similar bonds. So this is element, and these different bonds are compounds. In this box we have mixture. We have mixture of element and compounds. Mixture of element and compound. This element is which type of element? Diatomic or monoatomic? It is diatomic molecule, okay, because it is made up of two atoms. So two atoms combine together and they form molecule, but it is again element because it is made up of two similar atoms. While this is compound because it is made up of different atoms. In this case, again, you can see different balls. So compound, red ball only one atom, element, red ball only one atom, element, compound different atoms, similar atom, element, similar atom, element. So it means this is again a mixture, but this mixture is element in atomic form, element in molecular form, and compound. Mixture of element in atomic form, element in molecular form, and compound. Okay, while this mixture was element in molecular form and compound. Element, molecular form, and compound is in this box. Mixture is this box, and the mixture of element in atomic form, element in molecular form, and compound. This mixture is here. And in this case, you can see it is a mixture of different elements in atomic form, because all are single bond. So all are elements, but you can see there are different elements. Clear? In atomic form, suppose that this is helium, this may be neon. So this is a mixture of helium and neon which exist in atomic form. So this is a mixture of which element? Monoatomic element. Got it? Now by keeping all these points in your mind, you can solve the self-assessment exercise. Self-assessment exercise 1.7. The structures are mentioned down. Statements are there, A, B, C, D, E, F, G, H. And you have to read the statement. The first one is an element whose particles are atom. We have to see in this case first that which box has element whose particles are atoms. So you can see these brown balls. These brown balls are the elements and they are in the atomic form. It means that this box actually is related with the first statement. Okay. Second statement, an element whose particles are molecules. So you can see these purple balls. These purple balls contain similar atoms. So this box resemble with statement 2. Statement 3 is compound. Compound means I told you which have different bonds. Okay. different balls combined together. So you can see this one with a big and small ball. This is a compound. Okay, compound. So this box resembles the third statement. The fourth statement, a mixture of an element and a compound. Now find out the box which has element and compound. If you see this box, no, both are element, because element in atomic form, and the green ball is element in the molecular form. If you see this one, it has these three balls. They are compound, but these two similar balls are element. So it means that yes, this box resemble the statement that this is a mixture of element and compound. The next statement is a mixture of two elements. So this one, element in atomic form and element in the molecular form. So this box resemble the this statement. The last one is a mixture of two compounds. So mixture of two compound is this box. You can see this compound and two blue and this white compound. So this is a mixture of two compounds. So the last statement resemble this box. Okay. Coming toward this box, see the first one are all same molecules. So and each molecule is made up of different atom. So this is an example of compound. So this third statement resemble this box. Okay, and this one, all these are elements: similar ball, atomic, and similar ball, similar ball. So these are elements. Okay, this box is for the elements. So an element whose particles are a molecule, this box. An element whose particles are atoms, and this one, a mixture of compound, because this mixture is made up of three atoms, and so this compound is made up of three atoms, and this compound is made up of two atoms. So we have three atom containing molecule and two atoms containing molecule. So this box is for mixture of compound. Again, all these are green and element. So elements whose particles are molecule, because two atoms combine together and they form molecule, but they are similar atoms, so they form element. And this box is similar compound. Okay, and compound, compound, elements, elements in whose atoms are molecules, element whose atoms are atom, whose yeah, an element whose particles are atoms. And this is mixture of compound, and this is element whose particles are molecule. Hope you understand this lecture. Assignment is do self-assessment exercises 1.5, 1.6, and 1.7 in your notebooks. Thank you. Hmm. So